So what do you mean by electric field intensity? Electric field intensity helps us to determine the strength of electric field at a point. Okay, so here first let's discuss about the electric field intensity due to a point charge. So for that we must consider a point charge plus Q here. Consider a point P which is at a distance of R from plus Q charge. And here our aim is to find out or to determine the strength of the electric field at the point P. So how can we determine the strength of the electric field produced at the point P? So mainly three steps are there. First step is place a test charge Q0 at the point P. That is the first step. So place a test charge Q0 at the point P. And you know test charge Q0 is always a positive charge. Then the next step is to find out the electrostatic force experienced by this test charge due to our source charge. Okay, so as per Coulomb's law, this is one charge, this is another charge. So what will be the expression of force? And also these two charges are present in vacuum now. So as per Coulomb's law, what is the expression of force or electrostatic force? Yes, F is equal to K into Q1 Q2 by R square. Here Q1 is plus Q, Q2 is Q0. So you can write Q0 by R square. So this is the expression for force as per Coulomb's law. So this is the next step. And finally, we can find out the electric field intensity. Electric field intensity is denoted by the symbol E. So finally, we can find out the electric field intensity at a point using the expression F by Q0, where F is the electrostatic force and Q0 is the test charge. So what will be the expression? So this is our force and this is the test charge. So how can we find out the electric field intensity at the point P? Yes, F by Q0. So K Q0 by R square. Okay, then all divided by Q0. So what you will get? Yes, Q0 will be cancelled. Then what is left? KQ by R square. So this is the expression for electric field intensity due to a point charge. So Q is this source charge, K is the dielectric constant, R is the distance between point P and this charge plus Q. Okay, so this is the equation to find out electric field intensity at a point E equal to F by Q. There are two equations to find out electric field intensity at a point. What is the first equation? E is equal to F by Q0. Electrostatic force divided by the test charge. And also we have one more equation. E is equal to K into Q by R square, where Q is the source charge. So can you identify the main difference between these two expressions? Here we have used the test charge, but here we have used the source charge. So this expression involves the source charge and this expression involves the test charge. Okay, so these are the two ways to calculate, to determine the electric field intensity at a point. And from this expression you might have understood electric field intensity is a vector quantity. If it is a vector quantity, it will have a specific direction. Then what is the direction? Its direction will be same as that of the direction of force, electrostatic force. Okay, then what will be the unit of electric field intensity? So in order to find out the unit of electric field intensity, it's better to use this equation. It's a convenient way. Here electric field intensity is equal to F by Q. F means force. What is the unit of force? Newton. And divided by what is the unit of charge? Coulomb. So what will be the unit of electric field intensity? Newton per Coulomb. Newton per Coulomb is the unit of SI unit of electric field intensity. It's a vector quantity. and its direction is same as that of electrostatic force. Now let's discuss the nature of electric field intensity versus R graph. R means the distance between the point P and the charge Q. Okay. So in order to obtain the nature of E versus R graph, it's convenient to use this expression. E equal to KQ by R square, because this expression helps us to understand the relationship between electric field intensity E and the distance R. From this expression, it's very clear that electric field intensity is inversely proportional to the distance as R square. So, as the distance of the test charge from the source charge increases, electric field intensity decreases rapidly. Okay, but electric field can never be zero because the range of electric field extends up to infinity. It will decrease, but it can never be zero. So how can we plot the graph of electric field intensity with respect to the distance R? So in order to plot the graph, E is plotted along. E means what? Electric field intensity is plotted along y-axis and R is plotted along x-axis. And as R increases, as the distance of the test charge from the source charge increases, electric field intensity decreases. So what will be the nature of the graph? See here, like this. The graph should not touch the distance axis, because that will indicate the value of electric field intensity as 0 at that point. It should never happen. So it should go like this. The electric field intensity decreases with the distance, but it can never be 0. So this is the nature of electric field intensity versus R graph. Children, how will you express the electric field intensity expression in vector form? So in order to express this electric field expression in vector form, along with this expression, just add a unit vector r cap, which shows the direction of electric field intensity. Okay. Next, suppose r equal to 0. If r equal to 0, what does it mean? See, this is our source charge and this was the point P, and r was the distance between this point P and the source charge. So if r equal to 0, what does it mean? We are considering a point which is located within the charge itself. So if r is equal to 0, what will be electric field? Electric field will be undetermined, because anything divided by 0 will be undetermined. So if r equal to 0, as per this expression, electric field cannot be determined at that particular location. That means the electric field intensity we cannot calculate or determine the electric field intensity at the position of electric charge. That means at this position, at its own position of electric charge, it's not possible to find out the electric field intensity. Now here also we can apply the superposition principle if more than 2 charges are present. So here consider 3 charges are present in space, and these 3 charges are located in vacuum. Consider a point P. We need to determine the electric field intensity at the point P due to these 3 charges. So here this plus Q charge is a positive charge, and what is the method or what are the steps to find out the electric field intensity at any point? Yes, first just place a test charge Q0 here, and this is a positive charge. So what will be the direction of electric field? Here the direction of electric field will be like this. Let E1 be the electric field intensity produced by Q1. Then minus Q. This is a negative charge. So what will be the direction of electric field intensity? In the case of negative charge, its direction will be towards, because the electric field always acts towards a negative charge. At the same time, electric field acts away from the positive charge. And here in this case, Q3, it's a positive charge. So what will be the direction of electric field? Here, it will repel this test charge. So this will be the direction of electric field produced by the charge Q3, and this is the electric field produced by the charge Q2. So let it be E2. So at the point P, three electric field intensities are there: E1, E2, E3. So what will be the net electric field intensity at the point P? So the net electric field intensity E net is equal to, what is the superposition principle? Yes, it will be the algebraic sum of all the electric field intensities acting at that point. So it will be E1 plus E2 plus E3. Like this we can determine the electric field intensity at any point if more than two charges are present. So children, with this I am concluding my session. Notes of the topic and the YouTube video have been uploaded. Please go through that. And also attend the test seriously and post me the answers as soon as possible. We can meet in the next session. Till then, take care, stay home, stay safe and keep learning. Thank you.